Hello everyone. This is going to be our way that I'm going to show you the items in R.5 rational expressions. So on our first slide here, we talk about the idea of wanting to take an original expression and turning it into a lowest terms expression. So we have 12q squared minus 30q divided by 4q squared minus 25. Within this entire section, we're going to have opportunities to factor out items. We're going to use different methods where we'll look for the greatest common factor, or we'll actually factor it out into oftentimes two pairs of binomials using different methods. So the numerator, as you take a look at it, you can see that we have in the numerator 12q squared minus 30q. We have a 6 that's in common to both of the coefficients, so we can divide that out. That's where this 6 comes from. They also have a q in common, so we write down 6q. What's left over then is, if we divide 6q from both of our terms, both the 12q squared and the 30q, we get left over 2q minus 5. The denominator, if you notice it, is a difference of squares, and we talked about that formula the other day. Simply take the square root of the first term and the square root of the second, and we write them down. So the square root of 4q squared is 2q, and the square root of 25 is 5. We do a positive version and a negative version of this. In many of the problems that we'll work with in these rational expressions, we'll often get a similar term, top and bottom. So here we have a 2q minus 5 and a 2q minus 5. Those reduce. It's the same thing over same thing. So that reduces down to 1, leaving us with 6q divided by 2q plus 5. So we obviously like to take this a step further at times, and so when we look at the numerator in this particular expression, that one is a product of the same value twice. And so we had a formula whereby we simply denoted that if we look at the a term and the c term and we take the roots, so this would be m and this would be 4, the middle part is 2 times m times 4, negative 8m. The formula tells us all we need to do is come back over here and we get m minus 4 squared. If you didn't catch that, that's okay. You can go through and just do the a times c is 16. So a times c is 16. Factors of 16 that add up to negative 8. Well, factors of 16 that add up to negative 8 are negative 4 and negative 4. Therefore, we'd have m minus 4 times m minus 4, or m minus 4 squared. In the denominator, we notice that there is a 2 and an m in common. So we pull that out, and we are left then with 4 minus m inside. This is one of those very interesting kind of unique situations where top and bottom we have something that's very similar in appearance but not quite the same. So it doesn't happen very often, so if we don't catch it, it's not too horribly important, but we can make a quick little adjustment. In the denominator, if we factored out a negative 1 from this 4 minus m, we basically would end up with a negative on the outside and then negative 4 plus m. Negative 4 plus m is the same as, if you flip them around, you would get m minus 4. And then we just tack that negative on the outside. And so now that we have that, we notice that we have m minus 4 times m minus 4 up top and a single m minus 4 on the bottom. We can reduce that, leaving just one of the m minus 4s up top, which is why we get m minus 4 here. So negative m minus 4 over 2m. This really is okay with me as being our final solution. Our text takes it a little further, but I'm okay with this level here. Next idea of what we can do in simplifying is we can do multiplication and division. And so oftentimes when we do this kind of work, we'll just bring the numerators together in multiplication, bring the denominators together. And so that's what this step is. It's then, one way is we can break apart the coefficients, or sorry, the whole numbers that are there. So the 6 is 2 times 3, the 28 is 4 times 7, and z to the 6, they break it up into a z squared and a z to the 4th, simply because we have a z squared in the denominator. In the denominator we have 7 and 9, so 7 is 7, and 9 is 3 times 3. We look for similar terms, top and bottom. We have a 3 and a 3. We have a 7 and a 7, and a z squared and a z squared. Those all simplify down to 1, leaving us then with the other values. 2 for z to the 4th, or 2 times 4, which is 8, times z to the 4th. In the denominator, we have a 3. So we get 8z to the 4th divided by 3. So if you remember the method for factoring our trinomials with coefficient greater than 1 in front of n squared, we drop the 4 and we rewrite. With the exception then, we take the 4 times the negative 10 and get negative 40. And so now we're looking for factors of negative 40 that add up to positive 3. Well, that's going to be positive 8 and negative 5. At this point, we bring back in our a value, but we write it down as the denominator of each of these positive 8 and negative 5. We reduce if we can, and so when we get n plus 2 times n minus 5 over 4, we're almost there. All we do when we rewrite this is we take whatever was in the denominator and we write it out front in that parentheses. So the n plus 2, there's only a 1 in the denominator, so nothing to rewrite. The next parentheses, I apologize for my spacing issues here, is 4n minus 5. So we get the quantity n plus 2 times the quantity of 4n minus 5. I'm going to factor out this trinomial as well. This will be used on the next problem that you'll see, so you'll be able to understand where the binomials come from. We drop this first 2 and we rewrite and get n squared plus 3n. We take the first 2, the a value, and multiply it by the c and get negative 4. And so now when we write out our binomial multiplication, we write down our n's. Factors of negative 4 that add up to positive 3, that is going to be plus 4 minus 1. Our step always at this point then is to take our a value and divide the integers in our binomial. So we get quantity of n plus 4 over 2 times the quantity of n minus 1/2. So we get n plus 2 and n minus 1/2. And always at this point, if we have a value in the denominator, we swing it out front in front of the n. So our left-hand binomial, there's nothing to pull out, but in our right-hand one, we pull out the 2 and rewrite. So our new factored out version is n plus 2 times times 2n minus 1. This particular problem definitely is ramping up the difficulty, where we have 2 trinomials over each other and 2 binomials over each other. We're going to have to factor out these trinomials. I would highly recommend that you use the method that I gave you in class the other day. And so now that we have these factored out, now that we've factored out our work that we did, we can determine that what we have are Up top, we've got our factored out version of n plus 2 times 4n minus 5. We still have from the right side fraction 2n minus 1. On the bottom, the denominator, when we factored out the 2n squared plus 3n minus 2, we get n plus 2 times 2n minus 1. And so all we do now is we look across the numerator and the denominator as we look for things that are alike. We have an n plus 2, top and bottom, and we have a 2n minus 1, top and bottom. The math geek in me loves this kind of reducing thing here to where we just simply get 4n minus 5 divided by n plus 4. So with this particular problem, I'm not going to show you how, but you can revisit going through and doing our factoring of this trinomial. Simply just drop that 5, multiply it by the c, and then work out our steps for factoring the trinomial. If you do it correctly, you should get 5z minus 1 times z minus 3. In the denominator, when we factor this guy out, we get z plus 4 times z minus 3. This is a division of fractions, so the easy step to deal with that is simply to flip this fraction, the second fraction, and make it its reciprocal. So what was in the denominator moves to the numerator, what was in the numerator moves to the denominator. Once we do that, in that same fraction we pull out like terms, so there is a 2 in common between the 2 and the 8, so there's the 2. There is a z squared in common between the 2. So that goes there. Between the denominator, we have a 6 in common with the coefficients, and there's a z. When we look at everything together in the numerators and denominators, we notice that quite a bit reduces. So there's a 5z minus 1 that reduces, z minus 3's that reduce, z plus 4's that reduce, 2 z's that reduce, and we get z over 3 left over. This next problem is a little bit different. We're doing an addition now, and one of our big rules in addition is that you need to have a common denominator. And as we look at these denominators, they are not alike. There's some similarities, so we're going to have to adjust both of them to get them to be the same. We talk about, when we want that denominator to be common, we talk about the least common or lowest common denominator. Easy way to do that is to write down both values, break them apart, and once you break them apart, look at this. One of the values has a 2, so we're going to want both of them to have a 2. One of the other values has a 3. They share a 5, so we write that down once. And we want them to have the z to the 4th in common, which means that lowest common denominator, when we multiply it out, is 30z to the 4th. So both fractions need to be adjusted, because as is, they do not have that 30z to the 4th. To make the left side fraction 30z to the 4th, we change the 10z to the 4th by multiplying it by 3. If you do it on the bottom, you got to do it on the top to keep the fraction equivalent. On the right hand side, to make this 15z squared into a 30z to the 4th, we have to multiply the 15 by 2 and the z squared by z squared. If we do it on the bottom, we got to do it on the top, making our new fractions 9 over 30z to the 4th plus 4z squared over 30z to the 4th. The denominators are the same, so we rewrite that denominator. The numerators we just add together, and that is our simplified form. So this will be our last slide. This one is unique. It's a complex fractions. You don't see it very often. Notice that both in the numerator and the denominator of this fraction, there exists another set of fractions. But each of these sets of fractions has the same denominator. They both have an x squared. So one way to deal with this is to multiply the numerator and denominator by that x squared. And so when we multiply by x squared top and bottom, the entirety of each of the numerator and denominator, we get 3x squared times 4 over x squared is 4, and x squared times 6 is 6x squared, x squared times 1 over x squared is -1. That's it. Thanks for listening, folks. Take care, and God bless.